This is the final module of the video learning system. In the first lesson, you'll go through a package startup using a block logic diagram. Now, you worked with logic diagrams in the start, fuel, and oil system lessons previously. Here, all of the major events from each of the systems is combined into one diagram that will enable you to work through a package startup. Then, in the final lesson, after a review of the controls and indicators, you'll proceed through an actual startup and shutdown of a GS 1200 generator package.
This chart is a graphic representation of the major events that occur during a normal package start. In earlier subsystem lessons, you saw portions of this diagram. In this lesson, however, we'll combine all the subsystem events and discuss how they interact in the proper sequence to successfully start the package. When all the pre-start requirements are met, the operator first needs to set the system select switch to local. Next, the operator must push and release the reset switch. This action causes the malfunction lights to illuminate and extinguish and the ready-to-run light to turn on. At the instant the operator pushes and releases the start button, two things occur. The pre-lube timer begins its 10-second timing period, and the auxiliary lube oil pump turns on and builds pre-lube pressure. During the next 10 seconds, pre-lube pressure must reach at least 6 psi or an auxiliary lube oil shutdown will occur. If 6 psi is achieved, the starter will turn on as a result of the pre-lube timer timing out. At the same time, two other timers are activated, KT285, the 90-second start timer, and KT243, the 15-second crank timer. As the starter accelerates the engine, 13% speed must be achieved prior to KT243 timing out in 15 seconds, or a failed to crank shutdown will result. If 13% speed is achieved before 15 seconds, those speed contacts will energize KT241, a 10-second purge timer. This allows the engine to crank for 10 seconds to purge its internal flow paths of any trapped combustible gases. Once this is accomplished, the torch igniter is energized and the fuel valves automatically open. At the same time, another timer, KT246, a 25-second ignition timer, begins to time out. During this 25-second timing period, combustion should occur as evidenced by the exhaust temperature reaching 400 degrees Fahrenheit or 204 degrees centigrade. If this temperature was not achieved in the 25-second time period, a failed to ignite shutdown will result. If, on the other hand, all is going well and the specified temperature is sensed, the timing out of KT246 will turn off the igniter torch. The next event will be the lube oil reaching 35 psi, which will turn off the auxiliary lube oil pump. If lube oil does not reach 35 psi before the engine achieves 60% speed, the unit will shut down on low lube oil pressure. If lube pressure was achieved, then the 60% engine speed contacts will deactivate the starter, flash the field in the generator's exciter, and activate the voltage control regulator. Prior to reaching 90% engine speed, the control system automatically checks to ensure generator voltage has built up to at least 85%. If voltage did not reach 85%, the 90% speed contacts would have shut down the package on an undervoltage malfunction. If 85% voltage is achieved at or before 90% speed, then the start sequence is allowed to proceed. We must remember, though, that the engine needs to achieve 90% speed before 90 seconds, or a fail to start will result. If all is well and 90% speed was achieved within the prescribed 90 seconds, the 90% speed contacts will deactivate the generator's field flash and allow the electronic governor to assume control. Also at this time, KT265, a 2-second loading timer, is energized, requiring the package reach 100% speed within 2 seconds after 90% speed is reached. As long as this speed requirement is met, the 2-second timer will illuminate the ready-to-load lights. These lights indicate a successful package start. The engine is running at 100% speed with no load, and the generator is now ready to be brought online. Before proceeding with a package startup, you will need to become familiar with the location and function of the controls and indicators. You will find controls and indicators on several panels. The door of this freestanding control console contains an engine control panel and a generator metering panel. Some customer specifications call for a vibration monitoring panel and a generator winding temperature monitor panel. These options are installed beneath the engine and generator panels, as you see here. This particular package is only equipped with a generator temperature monitor. We'll also examine components installed on the DC circuit breaker panel located inside this console door and on the gauge panel at the forward end of the package. Let's begin here at the console with the engine panel. At the top of the panel are the malfunction indicator lights. A red light is a malfunction shutdown indication, while an amber light is an alarm indication. Lights are numerically coded to identify specific malfunction conditions. Pressing and releasing the malfunction reset switch resets these vital malfunction summary circuits and checks to see whether any bulbs are burnt out. On gas-fueled packages, two slimline style meters will indicate temperature and engine speed. Temperature is sensed by thermocouples located either in the exhaust collector or the turbine area. Engine speed is sensed by the magnetic pickup at the turbine assembly. Below these meters are several lights and switches. Each is identified by a nameplate. In the first row, the amber engine ready to run light illuminates when the malfunction reset switch is released. It indicates that the malfunction circuitry has been cleared and the start sequence may proceed. A green engine run normal light illuminates when the start button is pressed. When the engine reaches 100% speed, the green ready to load light will illuminate, indicating that the engine is ready to take on the generator load. Moving down to the next row, we see the system's control switch. It controls the 24-volt DC power to the control system. The three-position switch may be set to off, local, or auto remote. Here again is the malfunction reset switch, which I described earlier. Next is the system start switch. Pressing this momentary contact switch initiates the start sequence. Last on this row is the push-button stop switch. When pressed, it de-energizes the start control circuit to shut down the engine. Moving down a row, we'll see the engine speed isoc droop switch. During single unit operation, this isochronous mode provides for constant speed under all load conditions. When operating in parallel with one or more generators with the same governor systems, the isoc mode will provide constant speed control and automatic load sharing. The speed droop mode is used when operating in parallel with commercial power or when in parallel with generators with dissimilar governor systems. In droop, engine speed will decrease a predetermined amount as load increases to provide kilowatt load sharing. There is also an isoc droop switch for voltage, which we'll see in a moment. The engine speed decrease or increase switch is a three-position switch, spring-loaded to the off position. It controls the generator speed adjusting motor. The water wash switch is an optional item. Water washing of the engine may be required when the engine performance is not at its optimum. The two-position rotary switch controls the water shutoff valve for compressor cleaning. For excessive engine contamination, it's possible to clean with a solvent. Solvent cleaning requires that no fire be present in the combustor. Therefore, with the engine crank switch to the on position, it is possible to crank the engine to approximately 20% speed bypassing the ignition circuit. Some packages will have a fire protection system. This two-position switch arms or locks out the CO2 or halon discharge valve. Next, let's examine the components located on the circuit breaker panel inside the console. The reduced speed switch is used for water washing and abrasive cleaning procedures. With the switch turned to the on position, engine speed will be reduced and stabilized at 55 to 60% speed. The voltage switch needs to be positioned for the mode of operation to be used. During single unit operation, there is no requirement to share reactive load with another generator. Therefore, the ISOC position is selected. In the ISOC position, voltage will remain constant under all load conditions. The droop position is used when generators are to run in parallel. Also installed on the circuit breaker panel are the DC system branch circuit breaker switches. These switches are turned to the on position prior to positioning the system control switch to auto, remote, or local. When the engine reaches 60% speed, the hour meter begins to record the number of hours of engine operation. The start counter counts the actual engine light-off starts. Now, back to the front of the console, let's take a look at the left side of the door. The generator metering panel incorporates components that monitor and control the operation of the AC generator. Again, let's begin at the top of the panel. 4 slimline style meters indicate current, voltage, frequency, and kilowatt or kVARs. Current on each phase of the generator can be monitored on the ammeter with this 3-position switch. The voltage switch has 8 positions, making it possible to monitor bus line-to-line voltages or generator line-to-line voltages. The switch has 2 off positions. The watt or VAR meter has 2 positions. One allows monitoring of generator kW and the other monitors kVA. 2 lights are provided for use when manually paralleling one generator with another generator or commercial power. This 2-position switch arms the synchronizing circuits and lights. In the center of the panel, the voltage adjust rheostat is provided to adjust the generator voltage. At the lower right side of the panel is a 2-position circuit breaker switch. When moved to the on position, the alternator circuit breaker closes and the generator takes on a load. A green light indicates an open alternator circuit breaker, and a red light indicates the alternator circuit breaker is closed. Installed on the forward end of the package, you'll find the engine monitoring gauges. These gauges are the compressor discharge pressure, lube oil pressure, oil temperature, and fuel gas pressure. An oil level indicator is also located on the oil tank assembly. Now that you're familiar with the function and location of the various switches, gauges, meters, and lights, let's watch how each contributes to the start sequence. To do this, we'll be using this computer-controlled console here at Solar's training laboratories. For this simulated start, we'll be starting the unit with the intent of manually paralleling the generator to a live bus of one or more other packages with similar governors and voltage control systems. Before starting any turbine equipment, Solar recommends you conduct a pre-start checkout. This checkout can be easily done by walking around the package to look for any potential problems. Referring to the appropriate section in your student guide will alert you to items to check. Also, your operations and maintenance manual will list the items to check out for your particular installation. Prior to turning on the main DC circuit breakers, be sure to place the following switches in these positions: systems control switch to off, engine speed ISOC or droop switch to ISOC, water wash to off, engine crank switch to off, the fire systems lockout to arm, synchronizing switch to off, and the alternator circuit breaker switch to open. Now go out to the battery rack and turn on the main breakers. Once this is done, return to the console and place the voltage ISOC droop switch to droop and the reduced speed switch in the off position. With all these switches in their appropriate pre-start positions, the branch circuit breakers can now be turned on, followed by turning on the fuel gas. At this time, the package is ready to be started. To do this, I first need to turn the system's control switch to the local position. This action will energize various control circuits and illuminate this stop switch light. Next, I must press the reset switch. This action will illuminate all the red malfunction and amber alarm lights and the engine ready to run light. When I release the same push button switch, the malfunction and alarm lights extinguish and the engine ready to run light remains on. At this point, nothing else will occur until the start switch is pressed and released. When that happens, the green engine run normal light will come on, assuring that the start sequence has begun. Simultaneously, the auxiliary prelude pump will turn on and oil pressure will begin to build. 10 seconds after the start button is pushed, the air starter becomes activated and begins to crank the engine. Since the engine rotation will power the main lube oil pump, the auxiliary prelude pump will be deactivated when oil pressure reaches 35 psi. When the engine speed reaches 13% speed, a 10-second timer is energized to purge the engine of any trapped combustible gases. When this 10-second purge period is up, a command signal is sent to open the fuel valves, allowing fuel gas to the combustor. At the same time, the igniter plug becomes energized for 25 seconds and combustion occurs. Temperature and speed will now increase at a faster rate. At 60% speed, the starter is deactivated and the turbine should continue to accelerate on its own. Also at this time, a field flash is applied to the generator exciter that causes the generator's voltage to build up. At 90% speed, the field flash is removed and a 2-second timer is energized. At the end of the 2-second time period, the generator ready to load light comes on and the alternator circuit breaker permissive relay is armed. During this time, the engine will have attained 100% speed under the control of the governor. Slight speed adjustments can be made by momentarily turning the engine speed increase or decrease switch. This adjustment should be made to ensure that generator frequency equals bus frequency, usually 60 or 50 Hertz, depending on your particular service needs. Next, check generator bus no-load voltage on all 3 phases. If voltage is not normal, adjust as required using the voltage adjust control. With voltage and frequency properly set for no-load conditions, move the synchronizing switch to the on position. This causes these synchronizing lights to cycle on and off together. Adjust the generator speed until the lights cycle dark for about 4 seconds. This 4-second dark period indicates that the generators are operating very close to the same speed. When the lights are in the middle of the dark period, about 2 seconds, turn the breaker control switch to close. At this time, the circuit breaker close lights will illuminate. Now turn the synchronizing switch to off. Next, position the watt or bar meter selector switch to read watts. If necessary, adjust the engine speed increase or decrease switch to read the desired kilowatt load sharing. Now, position the same selector switch to read kVARs. Any needed adjustment to kVAR load sharing can be done by adjusting this voltage adjust rheostat. At this time, this generator package is operating in parallel with one or more other similarly governed generator packages. You should periodically walk around the package to look for any visible signs of malfunctioning equipment. Refer to your operation and maintenance instructions manual for your particular recommended operational checks. To manually shut down this package, you first need to unload the generator by opening the circuit breaker by positioning the switch to open. Next, press the system stop switch. When this happens, the post-lube pump is turned on while the engine coasts to a stop. Be sure not to turn off any circuit breakers until the post-lube pump has run for its specified time, usually 30 minutes. Also, the system's control switch can be positioned to the off, provided the oil tank heater is not needed. As we mentioned earlier, the control panel is equipped with malfunction and alarm lights. These lights are wired to a network of sensors and control devices that automatically shut the package down in the event of a malfunction. If this were to occur, you could easily refer to the corresponding number on the malfunction plates and learn the nature of the problem. Be sure to document which lights illuminate and any other unusual conditions. Your student guide will discuss each of these malfunctions further.